Okay, so now we're going to go over the dividing monomials with exponents. And if you have a question, I see someone is raising their hands. The raise your hand feature does not work. If you have questions, you want to type them on the questions box. So what would happen if we divide two monomials? So 3xy, we know by now it's a monomial, just one term divided by a one term. There are some set of rules that we have to follow to divide two monomials. So the rule says that, well, I mean, any monomial will have a part that is a numerical part, 3 over 12, it's just a numerical part, and that looks like a fraction. So we need just to go back in memory and remember how did we divided fractions or simplified fractions, because what we're looking here actually is dividing or simplifying this fraction. So we have 3 over 12. So we have 3 over 12, and on the variable part we have x and we have y, and also down there we have a y. And on purpose I am rewriting the variables, so I put each variable aligning with the variable that matches that from the bottom, so I'm able to, with my eyes, realize which exponents I need to subtract, because with division we need to subtract, and which numericals that we have to eliminate or simplify. So 3 and 12, the way we did that back in General Math 1 is to look for common factors between 3 and 12 and eliminate those factors. Well, since 12 is a multiple of 3, then 3 is a common factor. So if I divided on the top, if I divided 3 over 3, that will give me a 1, and 12 over 3 will give me a 4. So far I have my answer as a 4 on the bottom, and I have a 1 on the top. I'm done with the numerical part. I have xy on the top and I have y on the bottom. Now, if I'm dividing two monomials like these, and I realize that one variable like the x doesn't have a matching on the bottom, then x will just be as is, will just go down in my answer as is, and it was on the top, then it will stay on the top. What if I have y and y, they're matching, and they happen to have the same exponents, that's a 1 and a 1. Whether they have the same exponents or no, the rule says subtract the exponents. So it's going to be 1 minus 1 is a 0. So we have y to the 0 power, which always equals to 1. So our answer actually doesn't have a y, because now y to the 0 is a 1. Any number raised to the 0 power is a 1. So our final answer actually is an x over 4. We do not write ones in algebra, so that's why I just omitted the 1. X over 4 is the final answer. Let's do a more complex question. So again, I have a monomial on the top, a monomial on the bottom. The first step I'm going to do is rewrite both monomials, so I'm aligning all the like terms on top of each others. So I have a negative 25 and I have a 5 on the bottom. I have next an x squared. Do we have an x there? Yes, just put it down, write down the x squared. We have a y on the top and we have another y on the bottom. We have a z and we have a z. Okay, let's start with the numerical parts. We have a negative 25 over 5. Common factors are 5, so divide. Divide 5 over 5 is a 1. Negative 25 over 5 is a negative 5. So far I have negative 5 on the top and 1 on the bottom. Now we need to go to the variable parts. We have x squared on the top and x to the first on the bottom. We always subtract the top power minus the bottom power. So 2 minus 1 is 1. So our answer is x to the first power. So that x will just go up on the top. That's it with the x's. Y over y over itself. Y to the first divided by y to the first equals to y to the power 1 minus 1, which is y to the 0 power, which is 1. So I'm not going to write anything for that. And the same thing with the z's. They just cancel out with a 1. We do not write 1 in algebra, so our final answer is just simply 5x, negative 5x. Let's go to the third example. Rewrite just to organize everything if it's not organized. So a 5 and we have 100 on the bottom. We have an x to the 7th power and we have x to the 3rd power on the bottom. We have a y to the 2nd power on the top and we have a y on the bottom. We have a z to the 3rd power and we don't have a z on the bottom. Okay, but we have an m to the 2nd power on the bottom. Now it is easy for me to just, subtract the exponents of the like terms. First step, let's deal with the numbers just to get rid of that. 5 and 100, the common factor is 5. Divide over 5, that's a 1. Divide over 5, that's a 20. So 20 on the bottom. So far I have 1 over 20 in my answer. Now, x and x, 1 to the 7th power, which is the top power, and then the 3rd power, the bottom power. So 7 minus 3 is 4. 4 is a positive exponent. We're going to see later the negative exponent. So our answer is x to the 4th and will be placed on the top. Y to the 2nd and y, which is y to the 1st. 2 minus 1 is 1. So it's going to be y to the 1st or y. Z to the 3rd power doesn't have any matching. So it was on the top. It's going to go down as is on the top. M to the 2nd, no matching. It was on the bottom. Then it's going to stay on the bottom. And this is your final answer. I'm going to delete the 1 in front of the x to the 4 because we do not write 1 in algebra. And that would be the final answer. Any questions so far? Okay, I had a question and I'm trying to read that question one more time. I think something about the first example. If you want to send me one more time the question, I'm going to try to pull it up from here. Actually, I'm able to read it. Okay, so the question was for example 1, why can't the answer be simply 4x? And instead of x over 4, why cannot just say, oh, 4 times x? Well, if you want to rewrite this answer to make it still a correct answer, it is actually a 4th times x, not a 4 times x, because that 4 in the denominator. So another way to write our answer is 1/4 times x, if that would answer your question. Let me know if that is sufficient for your question that you have asked for question or example number 1 on the screen. Now let's do more examples, but this time we will have to deal with negative powers. So negative powers are just exponents, but instead of, for example, a 6 here for the z, you may see a negative 6. So let's see the set of rules that goes with negative powers if that what we have to deal with in this question. Let's do the same thing we have been doing. So I like to just rewrite the question, even if I think that those variables are already organized. I myself like to rewrite the question with my hands. So as I'm writing the question, I am understanding the question more. I'm trying to be aware of everything on this question before I go ahead and think, what should I do? And then we have y to the 5th and then z to the 8th. I'm going to apply the same rule. Start with the numerical parts. I have 30 over 40. The common factor is 10. Divide over 10, that's a 4. on the bottom, divide over 10, that's a 3 on the top. So far in our answer, we have a 3 on the top and 4 on the bottom. Now, x to the fourth divided by x to the third. 4 minus 3 is 1. So it is x to the first power on the top here. Now we have y to the fourth over y to the fifth. Now we have to stop here and realize that the top power is smaller than the bottom power, but we still have to subtract the top minus the bottom. 4 minus 5 is negative 1. So our answer for that part of the division is y to the negative 1 power, which make us put the y on the bottom with a positive power of a 1. So placing the y in the denominator of the answer is equivalent to the negative sign. So y to the negative 1 power equals to 1 over y to the same power, but this time is positive. And that's why I put the y in the denominator, not on the numerator like I did with the x. Let's do one more. Z to the 6th over z to the 8th. The same thing. 6 is less than 8, but we still have to subtract this way. 6 minus 8 is negative 2. So z to the negative 2 means that z have to be to the second power, but in the denominator. So this is our final answer. Same thing with this second example. So as you practice, you will find that those questions are not too hard. They look difficult, but they're not actually. Let's rewrite the question. A to the second, B and C to the ninth. And then we have a C, A, B to the negative 3 and C to the second. Okay, let's then perform the same thing that we did. 18 over 6, 6 is a common factor. Divide over 6, that's a 1. Divide over 6, that's a 3. Okay, so far we have a 3 and a 1. A to the second and A, 2 minus 1 is 1. So A to the first will be on the top because the 1 is a positive power. Okay, B over B to the negative 3. We're going to perform the same rule. So it has to be B, that's a 1. So 1 minus negative 3, which is the same as well saying B to the 1 plus 3, negative and negative, that's a positive, which is the same as saying B to the fourth power, and 4 here is positive. So B will go to the top with the fourth power. C to the ninth over C to the second. So 9 minus 2 is just a typical positive power, and that would be 9 minus 2, that would be a 7. So that would be C to the 7th power. And then we need to just rewrite the answer as 3ab to the 4th, c to the 7th. Since, you know, the 1, it doesn't mean anything in algebra, so we just omit that from the answer. And that's it. The last one I'm going to do quickly. We just now learned how to do that. 7, and you have a 28, and you have a p, negative 5, another p there, but with a positive 1 power. You have a q to the second and a q to the negative 6 power. The last one is r to the 6th and r to the 3rd. Now we know it's very automatic now, very, you know, second nature. With practice, it's going to become a second nature for you as well. Over 7, that's a 1. Over 7, that's a 4. We have a 1 over 4. P to the negative 5 minus 1. Negative 5 minus 1 is negative 6. So P has to go down with the 6th power. Q to the second minus negative 6. So 2 minus negative 6, the same as saying 2 plus 6 equals to 8. So 8 here is positive power. That will bring us the Q on the top. So Q to the eighth power. And then at the end we have r. 6 minus 3 is just a 3. It's a positive 3, so r would be on the top. And that's it. Any question? Anything that's not clear? Okay, so now I think we know how to deal with negative powers, how to deal with positive powers, what to do if we just divide it and we have a negative power to that variable. Where should we put it, top or bottom? And here is an example that you can try yourself. So I'm going to keep that so it's easier to read than the other screen, and then I'll give you to the other screen so you're able to select your answer. I'm glad I'm recording this part of the webinar now, because this is the tougher part than the other ones. And I'm very glad that there is a recorded webinar, recorded video on the squaring a binomial. So at least you have something to watch. And I will schedule another webinar for this second half of the series on Unit 1, so I make sure that is recorded. If you want to register for that and not attend it so you can receive the full recorded webinar, you're welcome to do that. Okay, let me change the screen to the possible answers so you're able to select your answer. Okay. So I'm glad that you're trying those questions. I really am not going to judge you if you have it wrong or right. I'll be happier if most of you have it correctly, because I want everyone to understand the topic, but definitely I'm not going to judge you saying, oh, this student did not have it correct. I'm going to be actually very glad that see some students having incorrect answers, so that way we actually know where they want to watch a webinar on it or do some questions so they do better in the exams. So please do not hesitate to share your answers. I'm not here to judge. I'm here just to direct you and answer your questions. Okay, I'm going to share my answer, and the correct answer is C. C is the right answer. Okay, let's look for other types of division. So far we have looked at dividing one monomial or a monomial over a monomial. What if we have a polynomial over a monomial? What should we do? Well, this method called the fraction method. And the way we call it this way, because we're going to end up distributing that denominator over each term on the top polynomial, like this. So I'm going to divide each term over the denominator. So negative 4x to the third over 4x. We have a plus here, so the plus will go the same, plus 20x squared over the same denominator, 4x, minus, because I have a minus, 16x over the same denominator. And guess what? For each of these fractions, we're actually dividing a monomial over a monomial, the same rules that we have been doing in the last two slides. So negative 4 over 4 and negative 1. So we have a negative 1. We have x cubed over x. 3 minus 1 is 2, so it's x squared. Or if I want to omit that 1, I'm just going to keep the minus sign. So it's negative x squared for the first term. Plus, I have 20 over 4. It's a 5. x squared over x is an x to the first, or x. I have a minus 16 over 4 as a 4. X over x just cancels out to a 1, so there is no variable here in our answer. This is our final answer, x negative x squared plus 5x minus 4. And this is how we divide a polynomial over a monomial. Do it again for the second question. It is an easier way. It's getting easier because we now can see clearly each fraction by itself over negative 9y. We have a plus sign, so keep the plus sign. 27y squared over negative 9y. We have a minus sign, 81y over negative 9y. Take each fraction separately. So 18 divided by negative 9 is negative 9. Y to the third over y, that's a y to the second. We have a 27 over negative 9 is a negative 3. Y squared over y is a y. And then finally, we have 81 over negative 9 is a negative 9, but we have a negative also here. So negative times a negative is a positive answer. So that would give you just a 9. Y and y will just cancel out. So this is your final answer. This is the quotient. This is the result of dividing this polynomial over this monomial. I think it's easy, right? Okay, let's look at an example. Gonna make it, try to make it quick since this topic is not too hard. So here's the question and see which answer is the right quotient for this problem. Okay, I'm gonna put up the answers so you're able to actually select your answers, and here you go. And be careful of the signs, because if you look at the answer choices, they look identical, just the signs are the ones that you need to decide on. Okay, I'm going to share my answer. As I said, when you get the recorded webinar, you'll be able to pause and do the question one more time. Okay, so the answer here is actually C. C is the right answer. And from looking at the first term, negative 14 over negative 7 should give you a positive. So this answer and this answer should just get eliminated, and we have to choose between these two. And that way, you know, you can kind of guess and make an educated guess based on the signs that you have in your answers. So C is the right answer if you work out the problem till the end. Long division. I get lots of questions on long division. I have this question on the screen, and this is the simplest kind of questions on long division, but I chose to bring it to the webinar just to start off watching and learning how the process goes with long division. In this case, we are dividing a polynomial divided by a monomial. Now, the question will say, divide 25x to the fifth plus 5x to the third minus 20x to the second plus 1 by 5x squared. To do the long division, we need to set up this division here with this long division sign correctly. So the polynomial has to go under the division sign, and the divisor has to go outside the sign. And from there, we can start dividing. And here's the steps that we're going to follow. And you will notice that those steps will repeat all over again until we find a number that's not divisible by 5x squared, and that would be our remainder if it's greater than 0. So let's start. 25x to the 5th divided by 5x squared. Let's take it one by one. So 25 over 5 is a 5. X to the 5th divided by x to the 2nd. Remember, x to the 5th over x to the 2nd, we used to subtract exponents. So it's going to be x to the 3rd. 5 minus 2 is 3. So the first step is divide. 2 multiply. 5 times 5 is 25. X to the 3rd times x to the 2nd will give you back the x to the 5th. Now you need to subtract. Subtract 25x to the 5th minus itself will give you a 0, nothing. Now it is time to bring down the next term, 5x to the 3rd. Now repeat, divide. 5 over 5 is a 1. X cubed over x squared is just an x with a positive sign, so only an x. Multiply. X times 5x squared is itself. It's going to be 5x to the 3rd. Okay, subtract. 5x cubed minus itself is a 0. Bring down the next term, which is negative 20x squared, and then repeat, divide. Negative 20 over 5 will give you a negative 4. And x squared over itself, of course, just will go away. So we only have 4 here on the top. 4 or negative 4 times 5 will give you negative 20. And negative 4 times x squared, just the x squared will just go down in your answer as is. Subtract. Negative 20x squared minus itself will just be a 0. Now bring the 1 down and try to divide 1 over 5. It will give you a fraction, but this is a sign that that's it for the division, and 1 will actually be the remainder of the division. So we can write the final answer as 5x cubed plus x minus 4. REM stands for remainder 1. And that's it. That's it. So we just repeating the steps: divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. And I have everything summarized on the right-hand side of that slide. Let's move on to a more complicated long division. And probably most of the questions I receive are on this kind of long division where you have to divide a polynomial divided by a binomial, not a monomial. The same thing I need to remind you, when you set up the division, you have to do it correctly. So this term, the dividend, has to go under the long division sign, and the divisor has to go outside. Let's perform the same steps with one alteration that we have to do since we're dividing over a binomial. Divide. 18 divided by 2 will give you a 9. X to the 4th divided by x will give you x to the 3rd. Multiply. 9 times 2 is 18. X to the 3rd times x is x to the 4th. But now we have to multiply 9x cubed times negative 3. And this is the only difference in the multiplication step. So 9 times negative 3 is a negative 27. And then x to the 3rd times nothing here will just go down as is. Subtract. So divide, multiply, subtract. Now we have 18. X to the 4th minus itself, just a 0. That will go away. X to the 3rd minus negative 27 x to the 3rd is the same as saying x to the 3rd plus 27x to the third. Don't forget that this is a 1 here. So we're actually adding 1 plus 27. That will give you 28 with a positive sign. 1 minus minus is 1 plus. Okay, and x to the third will just go down as is. Now bring down the next term. Minus 2x cubed or squared. Okay, repeat the steps. Divide. 28 over 2 will give you a 14. X cubed over x will give you x squared. Second step, multiply. 14 times 2 will give you 28 x cubed. And 14 times negative 3 will give you a negative 42x squared. Subtract. 28x cubed minus itself, that's gone. Negative 2 minus minus 42 is the same as saying negative 2 minus negative 42 is the same as saying negative 2 plus 42. So negative 2 plus 42 will give us a positive answer, and we're going to subtract 42 and 2 subtracted. That will give us a 40 and then x squared. Bring down the next term. Plus 8x. Repeat the steps. 40 divided by 2 will give you 20. And x squared divided by x will give you x. Multiply. 20 times 2 will give you 40. X times x is x squared. Don't forget, 20 times negative 3 will give you a negative 60. And we have an x there. Subtract. Negative 40, x squared minus itself, nothing, 0. 8x minus negative 60 is the same as saying, well, 8 plus 60. So that's 68x. Bring down the last term, minus 1. Divide. 68 divided by 2 will give you a positive 34. And x will just go away. So 34 times 2x will give you back the 68. X, and 34 times negative 3, 34 times negative 3 will give you 102. 102. 102, and it's going to be a negative 102, and we have to subtract. So subtract. This is will just go negative 1 plus 102 will give you a 103, and this is your remainder. You cannot do division anymore, so your final answer is the top answer here, 9x cubed plus 14x squared plus 20x, and then plus 34 with a remainder of 103. That's it. It's a long process, and that's why they call it a long division, but we repeat. Divide, multiply, subtract, bring down until there is nothing else that you can do. One more example. I know I went over the time, but this one I want to go over. This is the last example that we're going to go over in this webinar. The only special thing that made me bring this question is that if you look at the question at the top, you have an x to the third, and then right away they jump to the x to the first. So the exponents do not descend one by one. We should have seen an x squared in the question, but we do not have it. What should we do? How can we write out our long division here to do it correctly? And the way that we need to do that is to leave a space for the x squared that was supposed to be a part of our question, but it's not there. And that way, when we align our answers for subtractions, we are doing it correctly. Let's do that very fast. So divide 10 over 2 with a 5. x squared. Multiply. 5 times 2 is 10. X cubed. Multiply again. 5 times 4 is 20. 20 what? X squared, which did not exist here in our original polynomial, but we had a space for it. Subtract. That's gone. 0 minus 20 is a negative 20x squared. Bring down. Minus 2x. Divide. Negative 20 over 2 is a minus 10. X squared over x is an x. Multiply. 10 times 2 is 20, but we have a negative 10, so it's a negative 20. X squared. Negative 10 times 4 is a negative 40. X. Multiply. Sorry, subtract. That's gone. And negative 2 minus negative 40 is the same as saying negative 2 plus 40. So in this case, you're going to have a positive answer, but you're going to subtract actually. So it's going to be 38x. Bring down the next term. 3 plus 3. Divide. 38 over 2 will give you a 19. So plus 19. Multiply. 19 times 2 is a 38x. And 19 times 4 will give you 76. So it's a plus 76. Subtract. That's gone. 3 minus 76 will give you negative 73. And that's the remainder. Your answer is this with a remainder of negative 73. That's it. That was at the end of my webinar. We went over a bunch of things. For you who's going to receive this recording without having the part on FOIL or square binomials, I did not press the recording webinar until we started to divide the binomials. But the good thing, as I said, that there is an instructional video recorded for the squaring binomials. You're going to have an access to that through your student portal. Within that lesson, you will see a video that you can watch on squaring binomial. For the FOIL, in the handouts I have in this webinar, I have 3 handouts for you, for everyone, whoever is gonna have the recorded webinar, or with us now. You have an access to 3 handouts. One has extra resources that you are able to refer to on each topic, on the FOIL, on squaring binomials, on the different kind of divisions that we had today. So click on the watch link on the first handout under each topic, and you'll be able to watch a video on each topic. And then I have a practice link. That practice have a bunch of questions, and in some cases I have specified questions that you can work on that is consistent with our difficulty of this course. You can do that as well, so you didn't miss a lot today, even though I did not record from the beginning. So you'll use these extra resources to supplement if you want more practice and more instructional videos on each topic. You still have to read your unit and do the practice questions or discover more questions. On the other 2 handouts, you have instructions on where to find the answer keys for the discover more or the practice questions. So it is a nice way to assess yourself, even if you don't have an access to our school. If you're working at night on your studies at night and we're not open, you can assess yourself. Look at the other handout and see what other resources you have within your portal for this course. Any recorded lectures, the answer keys, where the units are, and so on. The third handout has a full instructions on how would you email your instructor if you need help. So each student have a different interface of their account. I have included all the interfaces that we provide our students on their accounts. Find the one that is your account, the type of your account, and follow the instructions. I try to make them as detailed as possible so you're able to get your questions to your instructors on specific topics. You can call the school, of course, 9 to 6 Eastern Time. You are able to schedule an appointment with either teacher assistant or an instructor for that course. The link is provided on the second handout. If I'm not mistaken, there is a link on the top that says schedule your appointment with your instructor. You can click on that link and schedule an appointment on the time that suits you. And you just need to specify which course that you need help with. And that's it. Thank you for your attendance. Thank you for staying with me over time. And as I said, I will announce another session for this webinar. So if you want to register and get the full recorded webinar, you're able to. Keep tuned for the upcoming webinars on Unit 2, Equations and Inequalities. I will announce the links through the message center. So as soon as you get that message, register for that webinar to be able to have more instruction on Unit 2, which is a tougher unit. Now we're going to deal with equations and inequalities. So I wish everyone good luck. If you have no questions for me, I'll end the webinar. But if you have some, I'll be glad to answer them quickly before I leave. Okay, you're welcome for everyone. Good luck in your exam. Do not feel that you have to take the exam now. You just take it whenever you're ready. Thank you and good luck.